In this lesson, we're going to talk about magnesium mining and look at the process through which pure magnesium metal is produced from the magnesium that's found in seawater. So within seawater, there are magnesium ions, and by extracting those ions from the seawater, they can be converted into pure magnesium metal. And several chemical reactions are required to accomplish this. So first of all, we have to separate the magnesium ions in the seawater from all the other ions. The magnesium ones are the second most abundant after sodium, and so we need a way to get the magnesium out. And so we're going to use a double displacement reaction so that it will produce a precipitate that can then be filtered. So if we react the seawater with calcium hydroxide, the magnesium and the calcium are going to switch spots, and you're going to produce magnesium hydroxide, which has a low solubility in water, and so will come out of solution and can then be filtered and used in another step in our process of getting magnesium. Before we talk about the next step in getting magnesium, we're going to talk about the calcium hydroxide that was used in this reaction. So the calcium hydroxide that is used in this initial reaction needs to also be created, and this is done using seashells and a series of two reactions. So seashells contain calcium carbonate. So the first reaction is to decompose the calcium carbonate. So if you recall, when metal carbonates decompose, they create the metal oxide and carbon dioxide. So that's what happens here. The calcium carbonate decomposes into calcium oxide and carbon dioxide. Now the calcium oxide that was produced is taken into the next reaction, and it's reacted with water to create the calcium hydroxide that we needed. Right? So if you remember this reaction, when calcium oxide reacts with water, we get a base, right? The metal hydroxide, calcium hydroxide. And this was a synthesis reaction. So now we have that calcium hydroxide that we needed in order to carry out the double displacement reaction and create magnesium hydroxide. So we can now take that magnesium hydroxide and neutralize it by reacting with it with hydrochloric acid. So this is a neutralization reaction. So we're going to produce water and then the ionic compound, which in this case is going to be magnesium chloride. So you can see how the magnesium and the hydrogen have switched places in this double displacement reaction, which is also a neutralization. So now we've got magnesium chloride in solution. If the solution is dried and then melted, it can create a pure liquid magnesium chloride. This pure liquid magnesium chloride is then used to create pure magnesium through electrolysis. So here's our liquid magnesium chloride. And so we're going to do electrolysis, which is a decomposition reaction using electricity. So we're going to decompose the magnesium chloride into pure magnesium liquid and chlorine gas. So after all those steps, we have reached pure magnesium. So if we go through all those reactions, so if we start with seashells, the calcium carbonate gets decomposed into calcium oxide and a carbon dioxide waste product. So then it's the calcium oxide that we're interested in that we take into the next reaction. We react it with water in a synthesis reaction to create calcium hydroxide. We then use that calcium hydroxide to react with the seawater and pull out the magnesium ions into a precipitate of magnesium hydroxide. The magnesium hydroxide is then neutralized by reacting it with hydrochloric acid to make magnesium chloride and water. And then finally, that magnesium chloride is dried and liquefied, and then a process of electrolysis, which is a decomposition, breaks it down into pure magnesium and chlorine gas.